CompTIA Tech Plus Complete Training Course. Exam Objective 2.8 Identify Basic Networking Concepts. MAC address. I will begin this video segment with the definition of a MAC address, where MAC stands for Media Access Control. Simply put, a MAC address is a unique hardware identification address issued to a networking device at the time of manufacturing. It's like a digital fingerprint for that device within a network. Every device that can connect to a network, including both end devices and networking devices, has its own MAC address. This is also very similar to how automobiles have VIN numbers, or vehicle identification numbers, that are unique to every vehicle manufactured. Now, you may be wondering, how are MAC addresses represented? Well, MAC addresses use the hexadecimal numbering system. Unlike our familiar decimal system with numbers from 0 to 9, hexadecimal uses a base of 16 and includes numbers from 0 to 9 and letters from A to F. If you need a refresher on hexadecimal, this topic was covered in the videos for Exam Objective 1.2. Now let's take a closer look at the structure of a MAC address. A MAC address consists of 12 hexadecimal digits, which is equivalent to 48 binary bits. The first part of a MAC address is the OUI, which stands for Organizationally Unique Identifier. This section comprises the first 6 hexadecimal digits of the MAC address. The OUI helps identify the manufacturer or vendor of the network interface card. The second part of a MAC address is the NIC or Network Interface Controller. It follows the OUI and consists of the remaining 6 hexadecimal digits of the MAC address. The NIC part provides a unique identifier for the device itself within the manufacturer's range of MAC addresses. This portion of the MAC address distinguishes individual devices produced by the same manufacturer. It's important to note that MAC addresses are globally unique. This means that no two devices in the world should have the same MAC address. Manufacturers issue these addresses during the production process. This ensures that each device has its own unique identifier, even if they are made by the same company. This uniqueness is crucial for proper communication and data transmission within a network. Could you imagine if a mailman had to deliver a letter to a specific address, but there were 2 houses with the exact same address? Which one would get the letter? The same holds true for a data packet. If 2 devices were using the same MAC address, which network interface would receive the data packet from the network switch? The switch and I surely don't know. Now, you might be wondering, how are MAC addresses used? Well, MAC addresses play a vital role in the communication between devices on a local area network or LAN. When you send data from your device to another device within the same local area network, the MAC address is used to identify the intended recipient. It helps ensure that your message reaches the correct destination. So why don't we look at this in action? First, we need a data packet to be sent. Luckily, the workstation in the top left of our diagram has a data packet to send to another device in our local area network. Now the workstation needs to encapsulate the data to be sent into an Ethernet frame. The Ethernet frame will include the destination MAC address or the MAC address of the device the workstation will be sending the data packet to. The Ethernet frame will also include the workstation's own MAC address, known as the source MAC address, and finally the data or payload that will be sent with this packet. Next, the data packet will then be sent out of the workstation's network interface card to the network switch. The switch will determine which network path is to be used to reach the device matching our destination MAC address in the Ethernet frame. And if everything goes right, our data packet will finally be delivered. All thanks to the help of MAC addresses. Thank you for watching. Subscribe for more great content.